everyone. Great to see so many of you join us to find out more about electrical and computer engineering at NUS. Before I begin, let me first introduce to you the team of professors and students that are here today to answer your questions. So we have our head of department, Professor Y.C. Liang, who is with us today. Prof. Tan Cheng Kong, he's our deputy head who look after our undergraduate programs and student life. We also have Professor Hari Gart, who co-chairs the computer engineering program. And myself, my name is Arthur, look after the outreach program. So among the students that are with us today, we have 5 students. We have Singing from the EE4. She's the former ECE Club president. She's currently doing the IDP program, and she also had a summer program at Hanyang University in Korea. Apruva, he's also from the EE4 cohort. He's doing an IoT specialization, and he went to the NUS Overseas College at Toronto. So if you have questions regarding NUS Overseas College, you can ask and he will try to answer your questions. We also have with us Joey Tan. She's from the E2 Poly cohort. She's our department undergraduate student council member and stays at Raffles Hall. Isabella Lu, she's from the CEG1 cohort. She stays at Ridgeview Residential College. And again, if you have questions regarding accommodation in NUS, you can either ask one of them. And then we have Yijie from the CEG3 cohort, who is our undergraduate student council presidents. And so all 5 of them are here together with 2 our admin staff, Eileen as well as Winnie, who will answer your questions. So let us begin by looking at today's global challenges and how an electrical and computer engineers can help to address these needs. So as you know, all growing cities face challenges such as managing traffic, caring for our aging populations, and creating sustainable living environment. And we are now at the most exciting and dynamic time and stand at the crux of the new industrial revolution fueled by digital technologies. Development in digital technologies are rapidly advancing, and the next frontier of technologies such as big data analytics, artificial intelligence, Internet of Things, and robotics will fundamentally transform the global economy and change the way we live, work, and interact. So next, I'm going to show you a video clip that highlight all of these opportunities. So the video actually shows you many things that electrical and computer engineers can contribute to realizing our smart nation initiatives, from electric vehicles, autonomous systems, modeling and simulations, and smart healthcare. In fact, the smart healthcare systems that you see in this video clip, uh, there's a startup company by one of our electrical engineering as well as computer engineering undergraduate. Two of them start up the company to roll out smart telehealth systems into our hospital. So what exactly is electrical and computer engineering? So electrical engineering is concerned with the study, design, and application of equipments, devices, and systems which make use of electricity, electronics, and electromagnetism that you study in your A-level physics, right? It has a wide-ranging discipline covering topics from nanoscales to very large-scale systems, right? From your quantum computings, nano devices, your integrated circuits that powers your smartphone, right? All the way to computers, AI, machine learning, to large systems such as power grids and Internet of Things and communication networks. So electrical engineering underpins the rapid economic growth in the 20th centuries. And some of the major technologies includes your radio and television, computers, diagnostic imaging, the internet, etc. Uh, it is enabling new economy in the 21st centuries, all right? Your mobile phones, the AI and machine learning, autonomous vehicles to provide our last mile computation, communication to homes, right? Bioelectronics, quantum computing, robotics, renewable energy, and data security. Whereas for computer engineering, it is a branch of engineering that integrates several fields of computer science and electronics engineering required to develop computer hardware and software. Computer engineers usually have training in electrical engineering, software design, right? Instead of only software or electronic engineering. And they are usually involved in hardware and software aspects of computing, from the design of individual microcontrollers to your personal computers and supercomputers. So it's a more focused discipline covering selected EE and computer science topics. So over here in NUS, our computer engineering program is actually a specially curated program, not just a mixture of some modules in electrical engineering and computer science. So for the Department of Electrical and Computer Engineering, we actually offers two full-time undergraduate programs. The first one is the Bachelor of Engineering in Electrical Engineering, and the second one is the Bachelor of Engineering in Computer Engineering. The Computer Engineering program is offered jointly by ECE Department as well as the Computer Science Department. And both of these programs are fully accredited by the Engineering Accreditation Board. That means your degree will be recognized worldwide. So next, we want to talk about our new curriculum. And this morning, some of you might have heard from our Dean, Aaron, on the new curriculum, and now I'll share a little bit more on that. So for NUS students, right, engineering students, to graduate, typically you take about 40 modules. Each module is about 4 MC, and in total, with 160 modular credits or MC, you get to graduate. So in the new curriculum structure, there's 15 modules on common curriculum. Out of that 15 common curriculum pillars, 6 are what we call general education pillars. These are things like modules such as digital literacy, communities and engagements, to help you to build a better person, that contributes to societies. And these are modules which every student in NUS needs to take. Next, the 7 common pillars. These are what students within engineering need to take. Artificial intelligence, design thinking, sustainable futures are just some examples. And then there's 2 module credits equivalent on the integrated projects. The 15 modules on major is what you will take depending on which major program you join. For example, electrical engineering, you'll take 15 modules from electrical engineering. If you do computer engineering, you'll take 15 modules from computer engineering. And what is new is these 10 modules under what we call unrestricted electives. So in this space, you are now have more opportunities to do explore different pathway, right? It can accommodate different majors, minors, specializations within the space, while providing the option at the same time for the more traditional engineering to go deep into a chosen field. For example, if you are somebody that likes satellites, you like semiconductors, electronics, you can still go deep in that under the electives. But there's opportunity for you to branch into different majors and minors. So this common curriculum actually is designed to offer 21st century competency to enhance our student career mobility and enable them to add value in their workplace. So these are some of the common pillars. Just now I mentioned about AI, there's makerspace, system thinking. So basically we are building skills for digitalizations, right? Some things that is very important as you have seen in the earlier video clips. Developing design and system mindset, emphasizing the value of higher order thinking and insight. So there's actually unlimited learning pathway, right, with such a curriculum structure, right? So over here in this particular figure, we see that again you have the common curriculum and then the major, but now with the 10 modules, unrestricted electives, you can go as a specialist where you specialize in all the electrical engineering modules, right? Or you can do a second major in maybe management or public health, right? Or you can also do a minor together with elective or specialization with elective, right? Within electrical and computer engineering, we have the IoT specialization and the robotics specialization. Okay, so some example of the possibility that you can explore. For example, let's say you do a major in electrical engineering and a major in management, then you can maybe work as a management consultant, right? Uh, if you are doing electrical engineering major, maybe with a minor in data engineering and a minor in public health, you can then be a health tech engineers, right? And look at solving problems very close to our public health, our community, right? Looking at data, analyzing the data, and understand how, you know, to craft different public health policy. Uh, if you do IoT specialization or minor in data engineering, then potentially you can become an AI engineer, right? Together with the depth in your electrical engineering major, you can do many things. For example, many students think that the semiconductor industry, the wafer fabs, you will have to wear your clean room suit and go into the clean room to do different things, right? But today, with all the automation, right, and the Industry 4.0 initiatives, right? Nowadays, wafer fab, what we call lights off, right? So everything is automated. As a AI engineers, they actually employ a lot of AI engineers who will focus more on the data. Together with your electrical engineering major in the semiconductor physics, you will understand the problem, and then with your knowledge in handling data, you can then become an AI engineer that helps to make better chips. Um, for computer engineering, there are also other different options. For example, maybe you can do a major in innovation and design together with computer engineering. This will help you to appreciate human elements, user interface and user experience, and empathy enabling solution of societal problems with novel approach to innovation, sustainability, and economic growth, right? You can also do a major in statistics, and for example, if you do a minor in data engineering and a robotics specialization, you can become a robotics or automation engineers, right? That help to automate many of the industrial processes to lead to better productivities. So a little bit more about our different specializations that we have. So within the Department of Electrical and Computer Engineering, there's actually two specializations that both electrical engineering and computer engineering students can take, right? So the first one will be Internet of Things. You can acquire expertise in IoT through courses that cover IoT systems and architecture, data science in IoT, and IoT devices and sensors. In fact, the value add from IoT is expected to be US $2 trillion. Today, we have one of our students that is currently doing the IoT specialization with us, and he can help to answer some of your queries that you might have. Robotics is another specializations that a student can embark, right? So opportunities for you to work on real-world robotics application in areas such as manufacturing, transportation, and healthcare. So you will acquire specialized skills through courses that covers robotics, system design, human-robot interactions, and intelligent robotics. And both of these specializations, you will get to work on, for example, either your capstone project or your final year project, right? You can work on related areas within that specialization. We also have a minor in data engineering. So for this one, essentially you'll study things, techniques, infrastructure and framework and services uh, to tease insight from the different data stream that's being generated, right? So you will learn AI techniques, machine learning, algorithms, etc., to look into all these things. Um, Within electrical engineering, there's also opportunities to specialize in areas such as artificial intelligence and data engineering, industry 4.0s, right, where we look at machines augmented with sensors, how they communicate with each other, with the server, the cloud, and the people, and look into visualization, decision making, etc. Right? You can also have opportunity to specialize in advanced electronics, where you'll be studying mainly on device physics, materials, process integration, IC design, and prototyping in a pervasive technology that influence our everyday lives, right? Space technology is one, renewable energy and electric vehicles for sustainability is another aspect. Of course, because of the unrestricted elective, there are other areas which you can study, right? For example, you can look into study more on wireless communication, your 5G communication networks, etc. So these are all different things that in your third and final year you can explore, okay? Similarly, for computer engineering, uh, we call them concentration areas, right? In your higher years, you can look into things such as large-scale computing, where you will look at things such as cloud computing architecture, security, and database, embedded computing, how computing system hidden inside everyday electronic devices, you will get to study them, interactive digital media, communication and networks, intelligent systems, right? Things such as, again, robotics or your UAV, right? How to develop these systems. And then finally, system on chip design, where various system components will be looked at integrating into a single chip, okay? Next, I'm going to show you some of our student projects. So earlier in the video clip, you have seen the first video clip, you have seen that some of students work on satellite projects. And in fact, our undergraduate students actually built some of those satellites that was previously launched into space. The video clip on smart nations has the telehealth system that, again, our undergraduate students over many iterations have developed and start the company to roll this out to benefits our healthcare system. So the next one that I have here is the Team Bumblebee, which is an interesting program, multidisciplinary student group, where we have students from electrical engineering, computer engineering, and mechanical engineering coming together to build autonomous maritime systems. Let me show you the video clip.
One of the main challenges of designing an autonomous system is knowing what you should be doing at the right place and at the right time. If we are just dropped into this competition, we should be able to go and do at least a few tasks without me having to code anything. That is actually very difficult to do.
The technology that we develop, the knowledge that we learn, I believe one day itself will actually be used in discovering something unique in the ocean. The ocean is just out there for us to discover. We just need more of this competition and talent.
Next, we have the unmanned aerial vehicles
group's
student
main
project.
focus is more on control of drones in GPS-denied environments, such as flying drones in indoor clusters environments other words, we try to make drones intelligent machines instead of merely aircraft.
So over here in the video clip, you see something that's very interesting where the students built UAV system to write Chinese calligraphy. And this can only be achieved if it is an autonomous systems that, you know, if we do control it manually, we are unable to write them together, right? The students have also participated in SG50, right? So for example, they have drones, right? In fact, 16 of these drones that do formation flight during celebration of SG50. So for example here, the word 50 is formed through the UAVs. Students also have the chance to work on projects related to healthcare.
Sign up for telerehabilitation. It's a low-cost program that uses real-time video conferencing, allowing therapists to treat and communicate with patients in the comfort of their own homes. The program is a result of a collaboration between the Singapore Millennium Foundation, the National University Hospital, Singapore General Hospital, and Ang Mo Kio Tai Hwa Kwan Hospital. Patients do exercises prescribed by therapists by following videos they can view on their iPads. Sensors are attached to the patient which transmit data and their progress via Bluetooth to the iPad. Therapists can find out if their patients are doing their exercises correctly and inform them if they're not. They can also check for anomalies using the data or watch recordings of the exercise.
So this actually requires skill sets that you learn from electrical engineering and computer engineering to help you to achieve all these different things. Our students also contributes to the fight for COVID-19. So during the circuit breaker, we went into the workers' dormitory to install an autonomous systems to help them to monitor their blood oxygen content. So beyond just engineering, what are the different other options that you can study, right? So we have double degree program. So currently we have double degree program between engineering and biz ed and engineering and economics. We also have more than 30 major and more than 70 minor programs. And you can scan the following QR code, which will give you more comprehensive list of the different major and minor program. So for example, electrical engineering, you can do a major with system engineering, innovation and design. Minor can be a minor in economics, financial mathematics, public health, etc. So you can also do an engineering and medicine track, right? So for example, there's this partnership between NUS Engineering and the Duke NUS Medical School, where at the point of admission, you can actually apply to be on this engineering and medicine track. And over here, what we will create is what we call, we are training engineering doctors, right? Clinician scientists that will help to change the way that medicine is going to be, healthcare system is going to be delivered to the public, right? So we prepare students with a background in engineering for leadership roles in healthcare as clinicians who can harness technological advancements for impactful innovations. So if you are interested, the following QR code will link you to more information regarding this engineering and medicine track. We also provide global exposure for our students, right? Students can take part in exchange programs. This exchange program can be a semester or two. There's more than 100 partner universities worldwide. And NUS Engineering is the only engineering school in the world to have exchange with both Oxford and Cambridge. You can also take part in shorter summer and winter programs, right? And our NUS Overseas College, right? So for students who are interested in startup entrepreneurship, this is the right program that you should explore joining. So the earlier talks about, there's some discussion on the NUS Overseas College, right? So you can intern at an exciting technology-based startup worldwide. And then through there, you then study at a partner university. Many of our students that have gone through this program, right, did go on and start their own companies or will then go back and join back that particular startup company. So for example, Over here, we have Darius Chung from Electrical Engineering, which went on to start up 99.co. For some of you who are looking for accommodation, you might have come across his this particular home rental matching platform. The next one is something that I believe many of you might have used this particular app before, right? Carousel. So Lucas Neo from Computer Engineering cohort actually went to the NUS at NOC at Silicon Valley, and when he came back, after he graduated, he actually started Carousel. So there are actually many different opportunity in terms of career prospect for our students, right? So we have students that went on upon graduation, work in investment banking, the more traditional engineering companies, telecommunication firms, the semiconductor companies, oil and gas industry, the Google, Facebook, Apple type of company, right? As well as more on R&D or defense science. So our students also continue to attract very good pay. So for example, if you look at our computer engineering as well as electrical engineering program, over the last 2 years, their gross mean monthly salary, actually there's an increase, and they remain very competitive compared to other university graduates. So why NUS Electrical and Computer Engineering? So first of all, the NUS General Education Program, the concept of training an educated person, and we will train you on different skills that is required for lifelong learning, right? So we need to continue to learn things even after we graduate. We also teach you on critical soft skills covering in project management, creating narratives, engineering professionalism as well. Within the program level for both electrical and computer engineering, there's a lot of experiential learning through project-based modules. You might have heard of our engineering principle and practice. You can find out more from our ECE websites. We have actually interview clips with students on how they find about their experience within these particular modules. And over at electrical and computer engineering, we actually have a lot of small group teaching and learning in our core modules, right? So although there are many students taking the modules, we break them up into different groups so that the teacher can interact better with the students and understands the different needs better, right? So we are continuing to explore different new pedagogies, and we have also embed presentation skills, etc., inside the different modules. So in terms of student experience, there's a lot of fun activities going on as well. Not only study, right? When you first join, we have things such as freshman party. Our students also go and do community service. In the higher years, we do things such as streaming talks on research exhibits to show you the different types of opportunity that you can have by studying different types of modules. And then, of course, by the time you graduate, we conduct graduation parties so that everyone can have a good memory within the electrical and computer engineering department. So this comes to the end of my presentation. Please visit our website for more information. This is the QR code that you can link there, and our hotlines as well as email address are there. You can ask us any questions that you would like to have answer. Let me refresh the student panel. Liz are here. Please feel free to continue to ask us questions. Thank you very much.
Thank you, Arthur. We have highlighted some questions in the Q&A panel for you to pick them up and perhaps get your panel to answer. Please go ahead and scan them through. Yeah.
So the first question that we have is it possible to become a computer engineer with a degree in electrical engineering? So this is something that's quite interesting because as electrical engineers, you do study things related to computer engineering as well, right? So maybe I can have our deputy head for undergraduate programs, Prof. Tan Cheng Kong, to help us to answer this question. Prof. Tan, please.
Right. Hello, everybody. Thanks for your question. Uh, I think there are a few questions related to computer engineering and electrical engineering. And sort of to address this question about whether you can be a computer engineer by studying electrical engineering, I think what you are sort of interested to find out is, can you learn what is in the computer engineering program by doing electrical engineering? Uh, the two programs are different programs. That's why, you know, we have two of them. Otherwise, you know, we wouldn't want to offer something that completely duplicates one another. So the flavor is slightly different. The computer engineering program focuses on computer engineering, which is related to computer systems, the hardware, the software. And then in electrical engineering, it is actually much broader because we cover aspects like energy, control, um, as well as telecommunications. We have a number of technical electives that are computer related in electrical engineering. So you can become quite close to a computer engineer, or at least become quite close to what a computer engineer learns at NUS, but it won't be 100% the same. However, you know, in electrical engineering, being broader, as I mentioned, it is applicable to many areas beyond computer systems, because I think a lot of the interesting areas nowadays are in energy, in telecommunications, in space technology, as well as, you know, sustainability solutions. So basically, I would encourage you to look at the descriptions for both electrical engineering and computer engineering, and ask yourself what areas you are interested in, and make informed a choice. Thank you.
Arthur, you're muted.
Thank you, Cheng Kong. I think definitely, if your interest is you're interested to learn about some of the AI, some of the machine learning stuff within the electrical engineering program, we will also be teaching that. And you can also take something like a minor in data engineering or the IoT specializations that will teach you some of the skills in the computer engineering side as well, right? So I see that there are some question related to whether you can do an electrical or computer engineering degree without physics background in A or O level. You you can you can don't have a A level physics background, but you need at least an O level physics background to join our electrical engineering or computer engineering program. Um, there's a question on what is the difference between a specialization, a major, and minor. Again, maybe I can invite Cheng Kong to answer this question again regarding the difference between these programs.
Right. Thank you for the question. Yes, I'll be happy to clarify the differences. So let's start with the industry track. The industry track is actually an informal guidance that we provide to students who are interested to work in different industries. And then what you can regard a minor or a specialization is they are actually formal programs that you can enroll in. The size of a minor is about 5 modules. Whereas the size of a specialization is also the same, but the specialization is actually deepening on the primary major. Let's say you are interested in doing electrical engineering, and because electrical engineering covers a number of areas, and let's say you want to specialize in the Internet of Things, or basically, as the name implies, specialization means you go deeper into the area. whereas a minor is to provide you with complementary training or exposure in a slightly different area. For example, a minor in management and so on. Data engineering is, not just related to electrical engineering. That's why it is a minor. But because it is offered in the Faculty of Engineering, it is designed to touch on a number of data-rich engineering problems, as well as to enable you to take advantage of emerging opportunities in various branches of engineering that require the competent or intelligent use of data. So I hope that gives you some idea on the difference between a minor and a specialization. And maybe I just would like to also mention a second major. The second major is an even bigger dose of a minor, where you have the opportunity to increase your exposure to an area that is slightly different from your primary major area. For example, if you did electrical engineering, you may want to do a second major in systems engineering, or you may want to do a second major in statistics or data analytics to actually learn more about related but not the same field as your primary major.
Thank you, Cheng Kong. So basically, a major would require you to study 10 modules, right? A second major requires you to study 10 modules, whereas a minor or a specialization will be 5 modules. Next, we have a question on, would you say that computer engineering will be software and hardware 50% each, or how does the distribution looks like? Maybe I can invite Professor Hari Ghat, who co-chairs the computer engineering program, to answer this question.
Yeah, hi. Thanks, Prof. Tay. I think it's an excellent question. We need to understand and appreciate the differentiation between what is the computer engineering, what is computer science. After all, the word computer is common to both. Okay. I want to sort of start off by picking up where Prof. C.K. Tham left when he spoke about, can an electrical engineer become computer engineer? I believe there is a continuum of knowledge and learning that takes place among electrical engineering, computer engineering, and computer science. So let me now come to computer engineering and computer science. I believe the major distinction between these two disciplines, they are closely interrelated, and one perhaps leans on the other, or one perhaps works together with the other to sort of provide a more comprehensive learning experience and environment to the students. Computer engineering is more focused on the integration of hardware and software. All right, so we would talk about, and of course, not to the exclusion of the others, but that's the major focus, these two, all right, hardware and software. And they are not being done in isolation of each other. So there is a significant amount of overlap between what you do when you learn about hardware and what you do when you learn about software. Many times these, in the context of a computing system, a computer system, these two things are designed together. So there is a co-design also that takes place. Computer science, on the other side, perhaps would say the platform characteristic, whatever the hardware platform is, the platform characteristic is known to us, and what can we do with this? So we talk about operating systems, we talk about the databases, we talk about the algorithms, and so on and so forth, right? So the computer engineer fellow would also look at maybe slightly deeper into the construct for the memory systems that will go as the foundation for the databases that we'll talk about, right? So I think they're kind of like complementary to each other, somewhat slightly different focus, but the heart and soul of these two, there's a lot of commonality between them. Thanks, Prof. Tay, for directing this question.
Thank you, Hari. So we have some students that are interested in the satellite program, and there's a question on whether there will be any more upcoming satellite projects for undergraduates in ECE to participate in. There's actually also one that asks about if he's interested in satellite technology, what type of engineering he or she should consider. Maybe I can invite Prof. Tan again to help to answer this question.
Thank you, Arthur. Yeah, I'm happy to receive this question because actually at NUS ECE department, there is a very strong program on satellites as well as space technology. There is a research center called the Satellite Technology Advanced Research Center, or STAR Center, on NUS campus. And a few professors from our department is actually working at that satellite research center as well. So there are many projects at the 3rd and 4th year levels which are satellite related. And we are currently designing a space technology specialization, which should become, offered in the coming few months. So definitely there are many opportunities for you to engage in projects as well as take modules related to satellite
I think there might be
Arthur, we
some
lost it.
technical
You can
issue.
move to the next question, please.
Yes. So I see that some students have some concern about programming background, right? Whether they'll be at a disadvantage if they join electrical engineering or computer engineering. I want to assure all students that this will not be a problem because we assume that everyone that joins our engineering program has never done programming at all. And so the teachers, will conduct clinic sessions for students that need more help. There's also other lessons. Every programming lessons that is being teach or taught, right, assumes that you come in without knowledge of that particular programming language. So do not worry about programming, right? So when you come in, we will teach you all these skill sets. So just now regarding the satellite project, if I'm not wrong, I believe that in a couple of years' time, we are planning for another launch into space, and definitely you are welcome to join the project team, right? So the students actually will start learning different things. In fact, one of the first module that students start to learn for satellite, right, is to build a balloon satellite, right, and to test out the different skill sets on that.
Professor Tay, may
Yes.
I add something to the last comment you made? I think satellites in general and in general space technology is a major area of focus and activity within the ECE department. So we very much encourage students, actually, those who are interested in satellites and broadly speaking space technologies, we would absolutely welcome those guys to join our program. Thank you.
Hari, may I play a devil's advocate hat for a short
Please.
One common question that comes, and I've done some outreach events in the last 2 months, is what is the difference between computer engineering and computer science? Perhaps this is a question that is targeted towards should a student take computer engineering or choose School of Computing, for example, computer science. It would be fantastic for our prospective students if you could shed some light on that.
I'm more than happy to share light. Okay, and I will answer it 2 ways. One way is, what is the distinction? And I believe that the critical distinction is the role that hardware plays. When you look at CEG, there is a greater role that the hardware would play. When you look at computing or SOC side, computer science side, it's a software that will play a dominant role, right? So we in CEG are looking at striking a balance between hardware and software. Now, traditionally, I can tell you this is very evolving, and we are not necessarily using last century's engineering to 21st century. So for example, I can give simple examples. Energy is one area. Traditionally, it used to be something that we in computing would not worry about. But as computing becomes so much immersive and pervasive in our lives, we need to worry about energy, right? So therefore, when you look at all of these things, we would say that even moving forward, even people who do computer science kinds of activities, they would need to look at energy considerations. So this again is a continuum, but the focus on computer engineering, when it comes to computer engineering, is more on the hardware. The focus is more on the software, but it's a continuum and it's a blend. So that's one part of the question. The other question that you asked, very relevantly so, which way should I go? Do I go for computer engineering or do I go for computer science? And I would think the students, and they're all listening right now, prospective students to NUS faculty, they're all listening right now. I would think they got to look inwards and ask that question to themselves. What is it that I am passionate about? What is it that I want to learn? I want to experiment with. I want to explore. I'm curious about, and so on and so forth. So I think it's not so much a journey of what programs we offer. It's more of a journey of the programs have tremendous flexibility that they provide me with like a buffet. But then I need to know what kind of food do I enjoy the most, or would I enjoy the most moving forward? And it's not so much a question of 4 years of engineering education. It's also what you can do with that engineering education moving forward as you graduate, enjoying the society at large. So I think it's a much broader question that you phrased for me. And I would say the discovery of the answers starts with the person himself or herself. Thanks.
Thanks, Hari. Arthur, we have time for perhaps one or two more questions. Please
Yes.
go ahead.
So I see that there are more and more questions that comes in regarding the space technology specialization, right? So this, like what Prof. Tan Cheng Kong has mentioned just now, this is something that is in the process, and by the time that you join NUS, it should be made available. So even if there's a student that mentioned that he has already chosen IoT or robotic specialization, right? So even when you have chosen those two specializations, when you come in, you can still make changes if your interest is in space technology, right? We always think that the most important thing is always study something that where your passion is, right? So don't worry about the economy, whatever job that is available out there, right? So the NUS program, all NUS program will train you to be adaptable, to learn, as you, even after you graduate, right? So this is a lifelong learning process, right? So Prof. Tam has come back online. Maybe he can add a little bit regarding the space technology specialization.
Right. Thank you, Arthur. Yeah, I think I was chopped off just now. So the space area, definitely we have a number of ongoing projects in that area. So when you sort of join the EE program or come to ECE department, you will have the opportunity to work on those projects. And as Arthur mentioned, the space technology specialization should be available by the time you reach your third year. I also want to touch on a slightly broader area, which is that of energy that Professor Gap mentioned as well. Many of you would know that, electric vehicles is a very hot area at the moment, as well as renewable energy and smart grids. So we will also be offering a specialization in electric vehicles and the smart grid, and this will actually equip you with knowledge to contribute to the fast expanding electric vehicle field. You may have heard the Singapore Green and Sustainable Plan 2030, where there will be 60,000 electric vehicle charging points island-wide. And all over the world, various countries are embracing the adoption of EVs. And so if you are armed with a degree in electrical engineering, you are definitely well positioned to contribute to this exciting area. Number of questions on computer engineering and electrical engineering. As I mentioned earlier on, electrical engineering is broader because you look at telecoms, you look at control, you look at energy, you look at semiconductors, whereas the computer engineering is focused on the computer hardware and the computer operating system. So both are very promising and good areas to be in. How do you decide? You have to ask yourself what you're interested in, and actually where you can contribute the most to, because there is so much that you can impact the world through clean energy, through 5G telecommunications, that an electrical engineering program can train you for.
Thank you, Cheng Kong. I think please continue to post your questions. We'll be here to answer them. Those questions that are not answered, we'll put up on our website. You can go there and look at the answer. For the interest of time, I think we have to come to an end for our session soon. Just before we go, maybe I would like to share with you this last slide again. Again, you can find out more information by scanning this QR code. You can also call us on our hotline. We will answer your questions, or drop us an email at askec@nus.edu.sg or askcg@nus.edu.sg. Thank you.